Hi, in this video, I'll walk through the thinking process of doing a proof. I'll take this example from linear algebra. Let A be an m by n matrix and B be an n by p matrix. Prove that if A has a row of all zeros, then AB will also have a row of all zeros. The first thing you should always do in any math problem is to understand exactly what it's asking. So number one, understand exactly what it's asking. Things that you should determine or what is given or the limitations, and what are they? As part of that, are there restrictions on the domain? What is the set that we're dealing with? And obviously, the third thing you should always make sure you understand accurately is what is the conclusion that you need to prove. So in this example, what's given is that I'm given that A has a row of 0. Well, what's A in the first place? Well, A is an m by n matrix and B is an n by p matrix. And that is the limitation here. In this situation, you can tell that A is m by n and B is n by p. The thing that should enter your head almost right away is, oh, A and B are not necessarily of the same size, not necessarily of the same dimensions. And the other thing you should notice is that n is the same for A as for B. And then you realize why it has to be that way. Because in matrix multiplication, the inside number of the dimensions gotta be the same. If A is, let's say, 5 by 10, then B has to start with the number 10 by something else in order for AB, the product, to exist. So need AB to exist. And that also leads you to know that the AB product will have dimension m by p. I don't know if it's important yet, but I know that that has to be true. And then what is the conclusion to prove? The conclusion is that the product AB has a row of 0. So this is a particularly uncomplicated question. Except for the row of 0, there's no other limitations on A and B. So it makes it easy for me because I don't have to keep a lot of things in mind. But that's basically step 1. Now, step 2 is that you should work out some strategy. Actually, I call it step 1 and 2, but once you get more used to this, 1 and 2 are kind of one big step. That is the preparation, is to work out some strategy. How do you work out these strategies? There are 2 parts to this. The second part is to try out different techniques, different proof techniques. But even before you get there, it's a good idea to try out a few specific scenarios. I don't know how much proof you did when you took geometry, but this involves, for example, if you're given something about a triangle, then you may try out something about the generic triangle, about an isosceles triangle, a right triangle, an equilateral triangle, and get an understanding of how things behave in the situation that you're given in the particular problem, right? And as if you did proof in geometry, you also remember that your teacher probably encouraged you to draw extra things. Okay, extend some line, draw some extra lines, see if something happen. That's part of trying out a few scenarios. And for that, I would encourage you to do two things. A is to try some special cases on the extremes. In geometry, for example, if it's a problem involving a triangle, I may try some triangle that are isosceles or equilateral. I may try some obtuse angle, especially if the problem involves angles, right? If the problem involves length, I may choose a triangle where the two sides are really long compared to the third side, right? I try some extreme to see how things behave in the context of the problem. And I would also try some generic, nothing special kind of case. So for our example, for this one, for example, I could do a very skinny matrix. I could do A is equal to just one row. And I could try B as, well, A is 1 by 4, then B has to be 4 by something. So maybe 4 by 2. Maybe throw in a negative here. So I'm going to try that. Then I'm going to try to see if AB has a row of zeros like it's supposed to. Well, A is 1 by 4, and B is, oh, I need one more row. B is 4 by 2. Then that means AB is gonna be 1 by 2. All right, AB, the first position here would be this row times that column. Oh, it's 0 times 1 plus 0 times -3 plus 0. Yeah, I can see that it's all 0. And then the second position is this row times that column. Oh yeah, also 0. I'm already seeing where this row of 0 comes from. Once I know the idea, I may not need to do anything more. But in this case, just to make sure things work, I'm gonna do one of these generic also. I'm gonna do a matrix that's, nothing special about it. I'm gonna try, let's say, how about 4 by 3? That looks normal. And I'm gonna put the 0 not at the top, not at the bottom. I'm gonna put it some random place in the middle. So 0, 0, 0. And up here, I'm gonna go 1, 2, 3, 3, 2, 1, 2, 3, 1. Maybe putting some negatives. So it is, this one is 4 by 3. So B has to be 3 by something. I'm gonna be doing 3 by 2. I don't feel like doing a lot of calculations. 1, 2, 3, 4, 5, back to 1. Maybe throwing some more negatives, maybe. Yeah. Okay, then the answer will be 4 by 2. Well, let's see. This position would be this row times that column. 2 minus 6 plus 15 is 11. This position would be that row with this column. By the way, I'm going to calculate in full because I'm doing this video demonstration. But you don't really have to. You can just see that it's probably not 0. But you have a non-zero vector times a non-zero vector. It'll be some kind of number. It may be 0 coincidentally, but it's probably not 0. So I could do that. If I were doing it on my own without you watching, I'll do that. But right now, I'm gonna do, I'm gonna actually calculate out. -1 plus 8 minus 3 7 minus 3 is 4. And now I'm down here. This position is this 0 times that. Oh, yeah, that's 0. And this position here is going to be the same 0, but times this column. So, yeah, that's 0. I see the pattern already. Okay, but I'm going to keep going. The third row is going to be this third row by the columns. So it's 6 plus 6 is 12, minus 5 is 7. And then this column, negative 3 minus 8 is negative 11, plus 1 is negative 10. And then the fourth row, this row times this column in here, and then times this column in there. 4 plus 9 plus 5 is 18. Negative 2 minus 12 minus 1 is negative 15. There's the row of 0. And I'm starting to see why that row is 0, right? That row is 0 because I start with this row of 0 and then I multiply by various columns. Well, no matter what column I choose, you multiply it by the row of 0, it'll be 0. I know what to do now. In my head, I realize a few things. There's a row of zeros in AB, same row as the zeros in A. In A was the second row, in AB it's also a second row, and I know why. Because it uses the row of zeros from A. That gives me my strategy. I will use that in my direct proof. I also know that I don't need to try out different proof techniques, because this comes from the calculation itself. So I can just use the calculation. I just directly prove by directly multiplying A times B to get my row of zeros. So that's what I know what I'm going to do already. Use a direct multiplication, A times B, to show where that row of zero is from. And it will appear at the same row as original A. Right, I've already made my decision on my strategy. I'm ready to do my proof. Of course, before writing my proof on paper, I'm going to do that on scratch paper first. Number 3 is to sketch the proof on scratch paper. I have my A, it has a row of 0. And I have my B. This one is M by N. This one is N by P. And in the AB matrix, I want to show that that row is all zeros. That means I need to specify where it is. And I know from working out the scenarios that it's the same row as in A. So it sounds to me like I should fix this. So I call this row I. Then this is also row I. The first position here is going to be row I of A times row 1, column 1 of B. It'll be 0 times something, so it's going to be 0. So this will be B11, B21, all the way down to BN1. And that will get me my first 0. And then I do it again, and again, and again, and each time I get 0. So it sounds like I should take a generic column of B and I multiply them together and I show that it is 0. So row I of A times column K generic. I is specific. It is the row with the zeros. K is generic. Well, row I of A is a bunch of zeros. What about B? The top one here is B1K. Down to the bottom is BNK. And that'll be equal to 0. That'll be the position IK of the AB product. This position IK here. Well, now that I've done this, I know a little bit better about how I organize my proof, right? For example, you are probably a little confused when I do generic column K here, and then I do a bunch of calculations down here, and then I sort of back up and I say, oh, that's position IK of AB, which is on this row. That makes it confusing. So I know that in terms of communicating idea, I need to say that first, right? I need to specify something about the generic column K, how it arrives at a generic position K in row I of the matrix AB. So now that I've done that through the scratch paper, it allows me to better organize my thoughts or better lay out my proofs. Once I know that, I'm going to write my proof now. It'll be very similar to what I did on scratch paper. I just move things around so that it flows better. Let I be the row of A with zeros. And I tell the person ahead of time what it is I'm proving. They know I'm going to prove that A row is going to be all zeros in AB. I'm going to tell exactly where that resulting row is. I'm going to tell them exactly that I'm going to prove that row I, same number I, of the matrix AB is all zeros. I may illustrate it, but it's really not necessary. I'm going to consider a position here. I'm going to consider the entry at row I, column K of the matrix AB. And I'm going to give it a name, C. So basically, matrix C is A times B. CIK is equal to row I of A multiplied by column K of B. A I1 times the B. I'm going to fill in with the B subscript later. A I2 ... all the way to A. Well, how many columns are there for A? A is M by N. So it's A I N times B something. Let's fill in B. B is column K. So it starts with B row 1 column K, 1K, and it ends with B row N column K. So B1K, B2K, all the way down to BNK. Well, all the AIs are 0. And therefore that Cik is going to be equal to 0 times B plus 0 times B. And is equal to 0. Since this is true for all case, then the row I of the matrix AB is equal to 0. And I'm done, QED. And then I would go back and look at my proof. And I realized that this part right here, the part where halfway through the proof, I introduced something new, and it's kind of disrupts the flow of the proof. So I would fix it a little bit by defining it earlier, get it out of the way. So I'm going to go let capital C equals AB. Then I can put C here. Now the proof flows more natural. It says, let I be the row of A with all zeros. So now I is fixed. We'll prove row I of AB is all zero also. So we're telling everyone ahead of time that we're going to prove the exact same row number is going to be zeros in AB. We define capital C as AB. We illustrate and what it is that we are given and what it is that we're going to prove. We're given that row I is all 0. We're going to prove that it's also row I here. This illustration is not necessary really, but I tend to do that because it helps me as well. It helps the reader see things, and it also helps me. And I consider the entry at row I, column K of C. I'm going to change that to C because I already defined C, might as well use it. Then Cik is row I of A times column K of B. Then Cik is equal to all of this, and finally it gets 0. And I might as well remind everyone what C is. Since this is true for all K, row I of matrix C, which is AB, is all zeros, QED. All right, I hope that helps you see how the thinking process goes from when you get the problem to when you get to a proof, and then after you got the proof written down, sometimes you go back and sort of clean it up a little bit, and it's true all the time, okay? No matter how experienced someone is, once you've written it down, sometimes you see something, you go back and you fix. That's very normal, and you should get in the habit of doing that. All right, I hope that helps. Any questions, ask in the comments section. Like, share, and subscribe for more contents, and thanks for watching. Bye.